We're going to move our discussion now towards body composition. Body composition, in this sense, refers to the relative proportions of fat mass and fat free mass in the body. So, why would we want to know this? Well, it's really important in determining health status. So, high levels of body fat are associated with several chronic diseases like type 2 diabetes, coronary artery disease, metabolic syndrome. There's a number of diseases that where the incidence increases as percent body fat actually increases. And also just your overall fitness level. It's nice to know your body composition. So if you think of the entire body and its mass, we can say that it's made up of part fat, and that'll be the fat mass, and then the other part would be the fat-free mass, which is everything else. So fat-free mass is basically anything other than fat. It's like muscle, bone, or organs. And then fat mass is just adipose tissue. So as far as classifications of fat, we have essential and non-essential fat. So essential fat is exactly what it says. It's essential for normal physiological functioning of the human body. So in other words, we need a little bit of fat on us to perform optimally. So this level is thought to be about 3 to 5% in males, 8 to 12% in females. Notice that I put approximately because not every source completely agrees on these numbers, but these are give you an idea of the ranges that are acceptable for essential fat in males and females. The non-essential fat is basically all the other fat that's not essential for normal human physiological functions of the human body. So this is commonly stored in adipose tissue. So it's useful in insulation, protection as far as padding goes, and some energy production also. So it's found in two major places. We have subcutaneous fat, which is just under the skin in a layer called the subcutaneous layer or hypodermis. And then we have visceral fat. Visceral fat is deeper inside the body. So it's found around our internal organs like the heart, our intestines, etc. So to show the difference between subcutaneous and visceral fat, you can kind of see subcutaneous is just underneath the surface of the skin, and that'll be all over the body. And visceral fat is deep. So you see how deep the visceral fat is. All right, so a little bit about fat tissue itself. So fat tissue is called adipose tissue. It's actually a type of connective tissue. The cells that make up adipose tissue are called adipocytes. And adipocytes, interestingly enough, can increase in not only size but also number. This is a pretty big difference than what we saw with skeletal muscle. So skeletal muscle, just kind of the cells just tend to increase in size when they get bigger. Well, fat cells have a greater ability to replicate and increase in number. We call that hyperplasia. So not only can fat cells get bigger, which would be fat cell hypertrophy, but they can also increase in number, which would be adipocyte hyperplasia. So the general strategy is, we understand it right now, is that the adipocytes have a limited capacity to get big, so they can get up to a certain size. But once they kind of reach that maximal size, then they start replicating and they increase in number, and that's when you get significant hyperplasia. So this tends to occur after you get up to a certain level of body fat. So just to give you an idea of approximately, and this is coming from one source, 66 pounds of excess body fat, and then you really start getting significant hyperplasia. The other interesting thing is hyperplasia is more likely to occur in younger individuals, so in kids. So just to give you an idea of looking at adult numbers, a non-obese, healthy adult is going to have somewhere between 25 and 50 billion adipocytes, where somebody who's morbidly obese will have lots more, 75 to 80 billion. So this is important to consider when you think about weight loss. So one of the ways that fat tissue is reduced when you lose weight is that the adipocytes get smaller. They do not as readily decrease in number though. So ideally you want to minimize the number of fat cells that you have in the body and not let those get too high, because once they're there, they're really hard to get rid of. And by exercise and diet, that's usually not enough to get rid of the fat cells, so they'll just shrink. And this partially explains why individuals who are morbidly obese, a lot of times they can lose a lot of weight really quickly, but they tend to gain it back relatively quickly also, because if those fat cells are just shrinking, as soon as their caloric intake goes up a significant amount, they're just going to increase in size again. So ideally, you would want to not have any more fat cells than your body needs. So just some body fat norms. So males and females, I just put some younger age categories to give you an idea. For males in the 20s, so you can see anything less than 11% body fat is considered excellent. So pretty good up to around 15 or so, then you're kind of in the average category, and so forth and so on. Females, due to the higher levels of essential fat, these norms are going to be a little bit higher. So another important point, not only are the norms based on sex, males versus females, but also age. So as you get older, it's common for your percent body fat to increase over time due to the normal aging process. So these two words, overweight and obesity, just wanted to kind of talk about what they are. So obesity versus overweight, obesity is really a surplus of adipose tissue. So when you get a lot of excess body fat on the body, there are cutoffs for what's actually considered obesity, and we'll get to that in a moment. But really that's what it is. If you have much more adipose tissue than your body needs, then you could be considered obese. Whereas overweight, on the other hand, is just means your body weight is higher than some standard. That standard is usually based on your height. So you could look at something like a height weight chart and see, based on your height and usually body frame size, what is your body weight supposed to be? And if you're above that, you're considered overweight. Overweight may not necessarily be a bad thing, because as we are well aware, people with lots of lean body mass, like a lot of excess skeletal muscle, that will increase your body weight, but that's not necessarily unhealthy. So you can be overweight and really healthy. Obesity is a little bit different, because that signifies that you have a lot of adipose tissue on the body that your body doesn't need. So how can we assess these things? Well, for obesity, we're going to get to, and the body fat issue, we're going to get to techniques later that are used to assess percent body fat. But as far as just being overweight, we can just use your weight relative to your height. And there's a few ways to do that. So we're going to start by looking at the classic height weight charts. So these were designed by life insurance companies to kind of assess the risk of individuals. So if you look for men and women based on your height and frame size, there is an estimated ideal body weight. So let's say if you were female, 5'6", with a medium body frame, your body weight should be between 130 and 144. So technically, if you're above that, then yes, you're considered overweight according to this chart. But like I said, that may or may not be a bad thing depending on what your overall body composition is. So as far as how they estimate body frame size, it's usually based on wrist circumference or elbow circumference, just to get an idea of kind of your overall body structure. All right, and the most commonly used way to assess if you're overweight or even obese for that matter, which is another issue, is something called the body mass index, or BMI. So BMI is a number that's calculated with your height and your weight, and the equation is this. So it's your body weight in kilograms divided by your height in meters squared. So we're going to go through an example how to calculate this, but these are the standard norms for BMI. So ideally, you're going to be between 18.5 and 24.9. That's considered normal, desirable. Anything under that is considered underweight. As you get from 25 to 29.9, that's considered overweight. And then 30 and above is considered obese, and there's different categories here. So this is how the big research studies that are done, like with the Centers for Disease Control, and just the stats that you see on the United States population, and they tell you so much of the population is obese. This is what they're using, a cutoff of 30 on the BMI. So you take it for what it is. It's strictly based on their height and weight, so it does have its limitations, which we'll address in a moment. But remember, you could have a lot of skeletal muscle mass and be relatively lean and still be overweight and even obese. So, however, we still kind of assume we kind of go with these stats using the BMI and assuming that they're relatively correct, because that's not the norm to have somebody with a lot of skeletal muscle mass that's really lean and weighs a lot due to that. So for the most part, using BMI is considered acceptable to get some overall stats when you look at it, thousands and thousands of people. So how to calculate it? You should be able to do this. So if I give you an example, somebody's 170 pounds, 5'10". So the first thing we need to do is convert to the right units. So assuming a kilogram is 2.2 pounds and an inch is 0.0254 meters, do the conversions. And then the most common mistake that is done when people are doing this equation is they divide before squaring. So you need to square the height, which is in meters, first before you divide. So I would rewrite this as 77.3 divided by 3.17, and obviously you can check my math on this, and I got 24.4 kilogram per meter squared, and that would be a normal BMI based on the ranges that I showed you earlier. So obviously BMI has its limitations. So this is an extreme example showing you two individuals, exact same height, exact same weight. So their BMI is going to be exactly the same. So they're both according to BMI classified as being obese. However, it's kind of obvious that one of these individuals is not obese. So this person looks relatively lean, but they just weigh a lot because they have lots of skeletal muscle mass. Their percent body fat is probably relatively low, whereas this person is likely correctly classified as being obese. So can we use BMI to predict body fat? You can, but it's not generally recommended. Just to kind of show you the relationship, and this is taken out of the American College of Sports Medicine guidelines book, but it kind of just shows you how varied it is. So in other words, if you're male and you have a BMI of 18 to 25, which is considered normal, and you're 20 to 39 years old, your body fat's going to be somewhere in this range. So it's really vague. So I generally would not recommend trying to estimate somebody's percent body fat based on their BMI. If you want to know their percent body fat, you measure it, and that's what we're going to get to later in this discussion. But BMI, it is what it is. It's your weight relative to your height. If we look at BMI and disease risk, or let's say health risk, mortality risk, we can see as BMI goes up, your risk goes up, which is understandable because we said earlier that lots of body fat is associated with several chronic diseases. What's more interesting is that at very low BMIs, the risk also goes up a little bit. And that is primarily due to chronic diseases that involve like muscle wasting and weight loss. So what immediately comes to mind, individuals with certain types of cancers lose lots of body mass and they're at high risk. HIV, AIDS, lose lots of body mass. And then you can get to things like eating disorders. Those individuals would have low body mass, so their risk would go up also. So we call this as far as sex differences in fat storage, so as a general rule, and due to hormones, females tend to store more fat in their lower body. Males tend to store more fat in their upper body. So we call the storage of fat in the upper body android obesity, and that's more of an apple shape. This is thought to be more risky, puts you at risk for cardiovascular disease, type 2 diabetes, metabolic syndrome. And then females tend to exhibit more gynoid obesity, which is more of a pear shape. And this would not necessarily be associated with as many cardiovascular problems or health risk, but more mechanical problems like moving due to the excess weight in the lower body. So how do we measure body fat distribution? So one way to do that, and this kind of ties into the apple versus pear shape, we can look at the ratio of the waist to the hips. So it's called the waist-hip ratio. Waist circumference divided by hip circumference. So waist circumference you generally measure at the umbilicus or If there's a thinner part between the umbilicus and the xiphoid process, that would be the waist measurement. And as far as the hips, it's just the widest circumference. And so just an average, if it's greater than 0.95 in men, zero point 0.8 in women, that's puts you at high risk of cardiovascular disease. So in other words, you're trying to stay away from that apple shape. So how do we assess body fat? We cannot assess body fat directly, unfortunately. So all of the measures that we have, even as good as some of these measures might be, they still only estimate percent body fat. So indirect methods are what we're going to use to estimate percent body fat. Some of the common techniques that we're going to discuss are hydrostatic weighing, which is underwater weighing, the bod pod, which is considered air displacement, skin fold measurements. There's something called DEXA, which is thought to be the most accurate. Then we have other measures like bioelectrical impedance. So we'll discuss all these methods of estimating percent body fat, but it's important to remember that that's what they are. They're just estimates. So the only way to really truly know your body fat would be to go in and actually dissect the fat out, which is not doable in a living human being.